So here we want to take a look at the four-membered ring. Cyclobutane, but means four, so I've got four carbons. This time to get the carbons to connect, it's not as difficult because the angles aren't as distorted from what they really should be. Right, so to make a square, the largest angle I can make there is 90 degrees. Really should be 109, a little bit larger than 90 because 90 degrees puts these electron groups kind of close together and they start repelling. That's unstable. So there's definitely some angle strain within this ring, making it unstable, giving it some ring strain. There's also more torsional strain. So if I make the ring perfectly flat, what do I see? I see the same thing I saw in the three-membered ring, the torsional strain all the way around. Every pair of hydrogens on adjacent carbons is eclipsing and their electron clouds are getting a little too close together. Note that the angle strain is usually a bigger factor than the torsional strain because angle strain involves electron pairs on the same carbon getting too close together. The torsional strain is only the electron pairs on adjacent atoms getting too close together. So they're not getting as close, they're not going to repel as much. However, when I create torsional strain between every pair of hydrogens all the way around the top and all the way around the bottom with all of that eclipsing, any two carbons I look down, I see there's eclipsing hydrogens there and there. It's really unstable all the way around. That's enough to overcome some of the angle strain and actually create a puckering of the ring. So if I pull these hydrogens together a little bit, I notice now the ring is not totally flat. So these two carbons here are a little bit below the plane of the other carbons. That alleviates some of the torsional strain, although it creates a little bit more ring strain. So by doing this, I'm kind of distorting the angles a little bit more and I end up with 88 degree angles, which is very close to 90. So 88 doesn't cause too much more repulsion than there would be with a 90 degree ring anyway. But there's definitely angle strain there. But by doing that, now I can kind of see some of the eclipsing. All right, so if I look at this carbon here as my front carbon, the one behind it is the back carbon. Notice these hydrogens aren't totally aligned anymore. When the carbons eclipse, the hydrogens don't quite eclipse. So I could move these hydrogens so that they do eclipse. They're right on top of one another. That would be a little bit less stable. So by staggering them just a little bit, they're no longer eclipsing, they're not quite as close and they don't repel as much. So that's why the four-membered ring is not totally flat, and neither are any of the other rings with more than four atoms because of the torsional strain all the way around, making that especially unstable.